Hello, my name is Olga Klintsevich, and the subject of our meeting today is domestic wastewater gravity systems. Traditionally, I would like to start with a short presentation and show you where you can find the information about our company, InstalSoft, about our software, InstalSystem 5, and also the information about the technical support that we provide to our users. So here is our website, instalsoft.com. You can find the information about our products, InstalSystem 5. Here is it. The information about available models in InstalSystem 5 is presented here. Available market versions. Here you can download demo version, buy a full version, or check the availability of the customized software. Here you can discover the advantages of our software. As you can see, the list is wide. New functionalities, new tools, new system elements. And here is our technical support. Please pay attention our help system. This is the online source which contains a lot of articles related to the working process with the program InstalSystem 5. These articles are divided into several sections. Here you can find product information, designing lessons, also sample projects which can be downloaded absolutely free and can be used while working with these design lessons, functions and tools, and also tips and tricks. The next is instructional videos, 10 hours of materials that show the program's possibilities step by step. Here you can find video materials, video tutorials, and also you can move to our YouTube channel, InstalSoft Global. Here you can find the presentation of our software in different languages, discover the information about individual models of the InstalSystem 5 package, find free webinars and tutorials, find the information about tools and functions, and also discover what new in our releases. Also here presented the information in different languages, so you can subscribe to our YouTube channel in order us to be closer to you and to provide you with timely information about our news and important events. The next point is trainings, complex program of individual and group training we provide to our users. Here you can find contacts with our support team, news in our releases, software technical specifications, and here a list of standards and methods that are used in InstalSoft packages. And also you can contact with us from here and from here. Here we are, and also find some information about our company and move to our networks, InstalSoft Global on Facebook and LinkedIn. And now let's move directly to the program InstalSystem 5. Here is InstalSystem 5 Manager. From the left side, you can find several buttons. Project Management. Here you can find recently edited projects and project management. Activation or deactivation of the program. Here is the information about the update ability. If this checkbox is on, the program will automatically check for updates and provide you to make it. Here is our help button, technical support. So from here you can send a message about the problem with the license or activation, about the problem with the project, and read the license agreement text. Here is our help system and our YouTube channel InstalSoft Global, our website, and also license change. And from here, we can create new project or open an existing one. So I opened my file. This is a multi-family house. It's a building with several stories. And we will start with the general data. First of all, let's define the project scope. We need to enable this point, sanitary drainage systems. Please note that we have a new model, rainwater drainage systems. We provide our users to design such systems in our program as well. There is an article dedicated to this subject in our help system, Designing Rainwater Drainage Installations. It has detailed description of the paths of designing such systems. And also there is a sample project that you can download and use while working with this designing lesson. But now we will focus on the model sanitary drainage systems. And now we will move to the catalogs tab. And here we will select the catalogs which we want to use in our project. And with these arrows, we will move these catalogs to the zone catalogs in the project. And now let's move to the stories management. And here we have a lot of novelties. We have a lot of new stuffs in designing sewage installations in general. And today we will talk about all these news precisely. And first of all, I would like to say that here we have several new features related to the building construction. We have the opportunity to create new, additional, and internal story levels. These elements allow to design installations in complex buildings without any problems and with a high degree of automation. And this has a direct impact on the internal sewage installations because they are laid with a certain gradient in relation to each other to the floor level, and the creation of additional and internal story levels with their specified elevation allows to automatically determine the gradient of the pipe runs laid on these levels. Another parameter that has a direct influence on the installation and is often ignored is the floor thickness. This is the thickness or the heating floors. And this characteristic is also important for the internal sewage installation and affects on the gradient of the pipe runs. So please pay attention to this characteristic. And now, a very important novelty which recently appeared in our program. This is point of passage of the stack to the collector. This is the place of connection of stacks to the sewage network. Unfortunately, this characteristic is often missed by our users, and as a result, causes problems with automatic sewage network routing. So don't forget about this. Please pay attention to this value. Here we have several options to be chosen. By default, we have such at a given distance beneath upper slab of the story. Please pay attention here. We have it. Let's change it at a given distance beneath lower slab of the story. And now you see how the situation here has been changed. We also will change this value distance of the passage point stack to the collector. Let it be 0.4, and you see how it has been changed. So once again, I would like to point out that this is one of the critical parameters which has an important impact on the switch installation in general. So please pay close attention and control it. Another parameter that you should pay attention to is the method of conducting of branches. Here we have two options, towards the floor or towards the wall. Today we will try both of them and we'll see what impact this characteristic has on the internal sewage installation. And one more important parameter that we will pay attention to here is distance from the floor to the riser connection point. For a given story, the default distance from the floor of the point at which the branches from the appliances will be connected to the stack. Let's change it to 0. And you see how the situation has been changed here. In this case, the pipe will be laid with a gradient so that in this point, the elevation of the connection will be 0. Please pay also attention to the fact that the calculations in our program are carried out in relation to the axis of the pipe. So it is also has an impact to the layout of the sewage system. And please note that one of the novelties in our program is that in the label of the element, in the label of the pipe, we have the ability to show the data in relation to the axis of the pipe runs and also in relation to the bottom, taking into account the diameter. We are moving on to calculations, standards, and options. Here we have two standards to be chosen. You know that the program responds differently to diagnostic dependent on the chosen standard. There are different settings in restrictions on pipe length, diameters, and so on. Differences in the project standards affect the way systems are filled, ventilation methods, and riser connections, and so on. So you can choose between these two. Building type, frequency factor, system, and here are general data that apply within the design practice. You can see these values which program provides by default. You can change them in the case of necessity. Go further, types and default data. Here we can choose the type of the pipe for branch, common waste branch, stack, waste collector, underground. We can choose from the offered list default methods of implementation of connection. Default types are the components. The next pipe sizing options, you can specify the type of pipe family, and also you can choose the range of diameters which will be used in the product. Also, please pay attention that we can control these parameters, resize diameters, retain user specified diameters, skip to pipe successes, size pipe fittings, brain ventilation pipe sizing method, and diameters used according to standards or real. And fixtures. Here we can specify default type of used fixtures. And also please pay attention. One more novelty is that we can choose default frame for the fixtures and use it in our project. Default connection systems. And I think that that's all with general data. And we are back to our working space. Here I have opened two windows, two working windows, 2D editor and 3D view. From my point of view, this is very convenient combination, but you should remember that you can always change screen arrangement and save it so that it will be suitable for you. And please also note that we have one more novelty. This is the ability to change story levels visibility. I will show how it works. Here it is, and if we open drainage tab, we will see such picture. As we don't have drainage system for a while, we see such visible story levels. And we will start from the stack element. Here it is. Let's place it here. Turn it. And in data table, we will indicate its symbol K1, its position from story -1 to story 2, pipe run type sanitary drainage. Let's place another one. Also, we will turn it. And here in data table, we will indicate symbol K1A, position from story 2 to story 3, change pipe run type, ventilation, and element on the top of vent stack will be ventilation pipe. Let's move to another worksheet, to the story 2, and for K1 stack, we will change element on the top of the stack, connect to another ventilation stack, and indicate it here K1A. And now you can see that the program has automatically created this pipe to connect two stacks. This is also one of the novelties in our program. Previously, we had to draw this pipe run manually. Now the program can make it automatically. And in our project, we will have several variants of the stacks. Let's place one of them here, K2, from story -1 to story 3. And element on the top of the stack will be ventilation pipe. The next one will be K3. Let's indicate it in data table. From story -1 to 3. And this one will also have ventilation pipe on its top. And the last one we will place here. And it will be A4. To story 2, and this one will have a admittance valve on its top. So we can observe already some created elements here on 3D view. You can see shadows of the steps, ventilation pipes, and also admittance valve and the part of ventilation pipe run. So we have three types of stacks here. The first one, this is the pair of stacks. One of them is sanitary drainage stack, another one is ventilation stack, and element on the top of the stack is ventilation pipe. This is the stack with deviation. Here it is, you can see. Next two stacks. These are stacks, sanitary drainage stacks with ventilation pipe on the top. And the last type, the last one stack here is sanitary drainage stack with element on the top air admittance valve. And now we will go to the basement and create here the network for our installation. We will place sanitary sewage outlet on our drawing and we will draw the network using gravity sewage pipe runs. And this way, and please pay attention that we will connect our pipe runs squarely. This stack and the next one. And finally the last. Here it is. So this is our network. This is 3D view. Here we have our pipe runs and the installation on this stage. So we already have created network on the base drawing. We already have stacks. And now we will place fixtures. You know that generally switch installation is designed in the last turn after the water supply installation has been already designed. And therefore, in the most cases, we already have fixtures placed on the drawing. But now I would like to show you the complete process of creating sanitary sewage installation in InstalSystem 5. And that is why I will show you how to place fixtures right now. The icons related to this process are located here. Let's choose solid ball and place it on our drawing here. And let's place also wash basin. Here it is. And now please pay attention to one more novelty which can be very useful. Here it is. Copy with the base point. Let's choose the components and indicate base point, for example, this one. And now when we will place objects on the drawing, you see that we have already some base point. And also please pay attention that now we provide the opportunity to make mirror copy and to set the mirror axis angle here and to rotate the objects with the appropriate rotation angle. So we paste copied objects. Let's improve the position of this wash basin. So this function is very useful. It can speed up the process. Instead of inserting one by one fixtures, you can just copy several of them, indicate one base point, and insert fixtures in necessary places. And we already can observe placed fixtures here on 3D. That's what we can see now on 3D view. And let's continue. So let's move to the kitchen. It is here. We will place a sink. Please note that we can always change the type of any element here in the table. Let's choose this one. Okay. Let's improve its location. And also we will place dishwasher. For example, here. We have one more kitchen on the opposite side of this building. It is here. And we can copy also these two elements. We can use the function copy, or we can use key combination Control C and then Control V to paste elements. And let's use these functions, which you already know. We will rotate copied elements and we'll place it here on this side of the kitchen. So as you can see, we offer several options for copying elements in order to make the system creation process as convenient and intuitive as possible. That's how it looks on 3D view. And we are moving further. Our next step will be placing sanitary appliances in the bathrooms. So it is here. We will place shower tray here. We will place wash basin and also washing machine here. And we can choose all these elements and use the function copy with a base point once again. Choose base point, and here we also have bathroom. We will place it here. So now we have all stirrers on our drawing, and now we will make connections of sanitary appliances to the stacks. And we will use this function, gravity sewage pipe run, and we'll connect each fixture to the stack. This one, this one, this one, toilet bowl. We can control our actions on 3D view. Here we have such pictures, such icons. The next step will be bathroom. We will connect these sanitary appliances with the stack. Next bathroom. And this wash basin. This one and this one. And the last one will be kitchen here. And we will connect here dishwasher and this sink. And now we can run our first calculation. Let's do it. Here's the icon. You can see that the icon is yellow. It is not red. That means that we didn't have any errors in our project and we can continue. So we can observe our installation on 3D view. We can already see nodes. And please pay attention that we can change the visibility of nodes here in the general data window, drawing options, visualization of sewage fittings. And here we also provide the opportunity to show in 3D view fittings for incorrectly sized nodes. And one more novelty that we provide to our users is the possibility to change the installation elements visibility right here in 3D view window in our working space. So let's see our 3D view. Here it is. We have gray color for correctly sized nodes, and we have such light color for incorrectly sized nodes. And sure, we need to improve this. One more great novelty in our program is that now it can be done easily with the use of this function. Lead the junction on the basis of sized main fittings. We just need to choose it. Run calculations once again. And now you can see that the program has automatically selected and sized fittings for these nodes. And please pay attention to one more very important aspect. This first connection to the stack, this first T, is made automatically by the program based on the default data that we put here in the general data window in the storage management. This elevation, distance from the flow of the riser connection points. This is very important value. This is very important for data that we should control because it has great influence on the calculation of the installation in general. So please pay attention here and we will be back to our working space. Please remember that in the data table, we can change this automatically calculated elevation of the connection, for example, to this value for each separate pipe run. Let it be 0.25. Okay, and we will run calculations. And now you can see that this P now is located on the other elevation. The same we will do for this connection. Let it be 0. Of course, it depends on the needs of each particular project. For our project, as an example, we will use these values. So now you can see that the connection point has 0 elevation, and this one also is calculated in accordance with the data that we put in the data table. If we have similar connections for each step in our project, we can put this data directly in the general data window, as I showed you before. In the storage management, we will just change this value in accordance with the needs of the particular project. And our next step is to improve the rest part of the installation. I will uncheck the story levels visibility, and also I would like to show you one more important aspect. For this washing machine, I would like to change approach direction. Choice of where the approach to the sanitary way is to be carried out from the wall side horizontally or from the floor vertically. By default, we have this one towards the wall. This data was taken by the program from the general data. You should remember we put it here, method of conduction of branches towards the wall. We will change it for this washing machine here in the data table. We will choose another variant towards the floor. And the same we will do for the washing machine towards the floor. By the way, you can change all the appliances of the same type using project browser. Here we need to find washing machine, you see, and we will just use this function select all. And in our case, we have 2 appliances of such type, and here we will change the type for both of them. And as we have already done this, we just now will see the effect. We will run calculations once again, and you see how the connection has been changed. And also I would like to change the position of shower trays. I will choose this one, and just using these pointers, I will turn it for this one and also this one. So we have finished with the situation for the connections to the K1 stack, and now we are moving here to the K2. Let's turn it to 3D view. I would like to turn your attention to the fact that we often have warning related to this connection. here it is, that gradient of pipe run less than minimum value. This happens because the distance from the floor to these appliances is 0. Program calculates real gradient of the pipe run in accordance with the elevations of sanitary appliances, with the elevations that we put in general data, and of course with the maximum and minimum gradient of the pipe runs. Please pay attention here that for this section, for this pipe run, real gradient is 15. Here is the value. If we change this value, for example, to this, let it be 8, and calculate the project, we will see that program automatically calculated real gradients for each pipe run, and we see that all nodes, all fittings for this connection are correctly sized. And you should remember that maximum gradient is one of the most important criteria for the layout of the sewage installation. We put it here in the general data window in the calculations, standards, and options. Here it is, and we can control it, we can change it depending on the needs of the installation for each particular building. And we are moving on to the case 3 stack. Here it is. And here, as you can see, we have such an incorrectly sized node, and we have 1, 2, 3, 4, 5 connections. I would like to make for this connection to the wash basin the elevation distance from the floor connection to the step as we made for the previous case. Let's calculate it. And you see that we have one sized fitting already. And for this node, we will use this wonderful grade function, our novelty. Calculate. And you see that program has automatically selected fittings and placed it on the stack on different elevations. Actually, you should know that all fittings in the catalogs of InstalSystem 5 correspond to their real dimensions, and therefore program automatically placed it accordingly. So here on 3D view, we can see them as they will be placed on the pipe runs in reality. So we improved all the fittings here for this case. We corrected the real gradients of the pipe runs. And now we'll turn to one common case that we often meet in the project, this unnecessary vertical section. So as we can see, the value of the real gradient for this pipe run is 1.5%. We can find this value in the data table, real gradient, here it is. And we can try to set different variants for the real gradient and see the result. But we can do much easier. We can correct the value of the maximum gradient to 999% and calculate the project and enjoy the excellent outcome. The value of the real gradient for this pipe run now is 36.25. Here it is in the data table, real gradient. Minimum gradient is 1.5% and maximum gradient is 999%. And we have one more place to be corrected. This is it, A4 step. And you see that here we have one more problematic place, one more incorrectly sized. Now let's check on its visibility. You see that it has light color. And what we will do here, we will also change the value of the real gradient of this connection. So it can be changed here or here in the data table. I will put 8% and let's run calculations. So you can see that the color of our fitting is gray. And here in this place, everything is okay as well. And we are moving forward. So we improved the installation here on the 0 level. And now we can copy this part of the installation to the next stories, as we have several of them here. So for these purposes, we will use the function copy selected elements to the multiply stories. We will choose necessary elements. And here we will indicate from story 1 to story 2. Okay. And now we can see the effect of this function. And also here on 3D view. Now we need to run calculations once again. And I would like to pay attention to this warning. Fitting connecting pipe rounds not sized required angle 79 degrees. And we see this connection here. What we need to do in such situation, we will choose this step and change this offset angle to 79. Run calculations once again, and you see that everything is okay here, and by this way we can correct all rest warnings. And we go down to the basement, and here we will improve the network. The first thing what we will do, we will correct this connection of the stack to the network. So now we have such a variant, and to make this transition more seamless, we will do the following. We will go to the general data, and here in the types and default data, we will choose another method of implementation of transition from the stack to the waste manifold. We will select this one. Let's go back. And let's run calculations. And you see how these connections have been changed. It is very important in the sewage installations to make such transitions more seamless, and you see that it can be done very easily for each step. And also for these places. Such seamless junctions can be referred as chamfers. And if to continue the topic about chamfering, we will pay our attention to these straight piers We also can change them easily with the use of this fitting. I will turn the view to make these tiers more visible. We run calculations once again. And now you can see how these tiers are represented on the 3D view. And on 2D, we will turn on the visibility of notes to simplified here. And on the printout, you can see that all the junctions are perfect. And continuing the topic of the network, I would like to show you on 3D view how the change of the parameter, which we have indicated as one of the most important, impacts on the lane of the network on the basement. So here it is. Let's go back to the general data. And here you should remember this setting point of passage of the stack to the collector. We have indicated it as at a given distance beneath lower slab of the story and also indicated the value of the distance. Let's change it to this one beneath upper slab of the story. Go back to the 3D view and calculate our project. So you see where the network is located now. And here in this scope, I would like to remind you about one important aspect of the calculations of the network in our program, that all points of the network, all points of the installation in general, are calculated taking into account the elevation of the axes of the pipelines. So that's how the network is looking now. And we see that some pipes are located partly inside the slab. Because of this, that the program automatically calculates the connection points and the elevation of the pipe runs based on the axis. It doesn't take into account the diameters of the pipelines. I unchecked the visibility of the slab, and you see that the connection is made directly beneath upper slab in relation to the axis of this pipe run. So let's change it back to our previous meaning. Let's recalculate the project and we return to our original state. And now I would like to show you what are the possibilities the program offers to our users in terms of graphic design of the product. Let's open search window. And here we will add new search. We will call it waste branch up to diameter 15. Here we will choose pipe run, technical data, location, waste branch, diameter 250. We can save this new search in the program settings. Okay. And now let's find all pipe runs in these parameters. Select all, and you see all these pipe runs are highlighted in yellow. Here in data table, we will change the element style, waste branch up to diameter 50, and you see that these branches became white. We change the appearance of these sections because they will be of polyethylene pipes. This element style was created here in the general data window in the component styles, sanitary drainage, pipe run, and here we just need to add new row to set the title of it and to add the properties of the element appearance. So as you can see in InstalSystem 5, you can design your project according to almost any needs and wishes. And at the same time, it doesn't require any serious efforts and time costs. I would like to show you some specifics on how to design various elements of the installation. We will start from the drain. Here it is. This element is often used in the project, and we will place it here in the basement and we'll connect it with our installation. So you can see it. As you have already realized, the level of automation of the design process in the program is very high. But at the same time, in the case of necessity, we can perform manual adjustments quite simply and with a high degree of efficiency. And on this example, it will be seen very well. So we have made the connection. Let's calculate the project. And you see how the program made the automatic routing of this pipe run. But what should we do if you want to make a sloping section here, for example, and thus reduce the number of fittings for connection? We do not need to remove unnecessary from our point of view sections and try to make the connection manually. The program will do it automatically. We only need to perform one simple step. Here in this point, maximum gradient, we will indicate this value, maximum gradient 999, and let's run calculations. And you see the effect of this manipulation. We have such sloping pipe run and only two connection points here and here directly to the drain. And the second variant, if you would like to make vertical section here, it also can be realized very simple and automatically executed by the program. We just need to insert dividing point. Let it be here. And to specify the elevation of this point, taking into account the elevation of this one. It is minus 0.86. Here we will indicate minus 0 and 7. and calculate the project once again. And you can see that program automatically made this connection for us, and we do not need to draw any pipelines or to delete some sections to make such connection. And here we need to pay close attention to one more important aspect: location of the piping section. Here we have waste vault, but this one is waste manifold. This one, and also this one, and all the rest pipe sections, which are located here on the basement, belong to waste manifold. It is very important to pay attention to this assignment because based on this characteristic, the program assigns data from the general data which are set by default. And that is why there can be some inconsistencies in the product. So it is very important to pay attention to what type the given section belong to, and if the program automatically assigns the wrong type, it is possible, for example, when there is a large number of fixtures and the network on the same floor, we can change this position, this location manually, and we should do this to avoid diagnostic messages and even errors. And also here, please pay attention if we will change the location of this section to the waste manifold underground and run calculations, all subsequent sections will be changed accordingly. So here is the results window. Here we can find general results for sanitary drainage, number of sewage outflows, sewage sources, number of drainage pipe runs, sanitary sewage outlets, outflow data, nature of wastewater, outflow elevation, sanitary drainage and ventilation pipe runs, the table with a list of pipe runs. We can find any of them on the 2D editor and on 3D view, drainage stacks, sanitary ware, and also bill of materials, list of pipes, pipes fitting, and couplings, list of tap assemblies and water outlet points, and also the list of frames if they are in our project. And we are moving to the end of our project. One of the last phase will be generating schematic view. Let's go to the basement and place here starting point. This is one of the most important elements of the schematic view. The next step will be using this function, generate worksheets with schematic views. Let's run it and discover the result. Here it is. Here is the schematic view. and let's observe what possibilities provides the starting point. It is used to adjust the properties and visibility of the elements of the schematic view. As you can see, we can control maximum length of the pipe runs to be heating, rise it determines direction of schematic view, generating schematic view, and here in this section we can choose which elements of the schematic view will be presented, labels, visibility of room areas, and also additional story levels. This is one of the novelty in our program, one of the great function which can be used in the project, and we also will have a separate webinar on this subject. So you can see how fast is the process of generating the schematic view. It is rather wide topic, and we will have also separate webinar, and we will discuss there all possibilities which program provides in this sphere. The final step will be exporting our drawings to DWG file to IFC and printing. We will do the here on this working space in printout. Please pay attention that on the drawing we will see all fittings. So first of all, we will insert page layout. Here in the data table, we will choose necessary format of the paper, its orientation, scale, and other data. Then we will put drawing chart. The type of drawing chart we can change here in the data table. And print our drawing. Here it is. Export to DWG file is here. We can control the properties of the exporting, choose the layouts of the elements, worksheets which will be exporting, and also choose the file to which the worksheets will be exporting. Here we can choose the place, the folder where the exporting will be made, and then execute. I think everything is clear here. IFC export. Here is the table for executing the export. We can also control the settings of exporting. So our project is ready. Now we will observe different methods of implementation of nodes on several cases. And here is the first case. Here we have two toilet bowls which are connected to one step. It is rather common case. For this node, we will check on this function, split the junction on the basis of sized made fittings, and run calculations. So you see that the program automatically selected and placed these two tiers. This selection is determined based on the data that we put in the general data. Here, method of implementation of pipe runs to stack connection. We have all by default, but we can choose any particular method from this list. And in this case, program will select all nodes in the project based on this chosen method. And if we would like to change the method of implementation for each particular node, for example, for this one, we will do it here in the data table, method of node implementation, and choose some from this list, for example, branch 45, and run calculations. So you can see how the situation here has been changed. Let's do the same for this one. Calculate the project. So you see these two tiers. The elevation of the upper connection is taken by the program also from the data that we put in the general data and is specified here in the data table. We also can change this value in the case of necessity, and then the program will locate the upper node, and depending on this location, will place this node. So you can see that we can easily control and change the type of each fitting, each connection, and also its elevation. You should know that when selecting a fitting, the program carefully checks whether the fitting is suitable for a given connection. For example, for this one, we will change the type, maybe for this range 67. Let's calculate, and you see that the program cannot implement it in given situation. We can check on the visibility of incorrectly sized node, and you see that program can select any node for this case. Let's return back this branch. Everything is okay here now. And also for this connection, for the lower connection, I would like to delete this unnecessary vertical section. You should remember that for this situation, we will change the value of maximum gradient for this one, 999, and recalculate the product once again. So you see that now everything is correct, everything is suitable. And we move to the next story, to the upper level. Here we have the same situation. We have two toilet bowls and one connection to the step. But we will realize in different way this connection here. So in the data table, we will uncheck this function, allow implementation with two fittings. It will be our first step, and let's calculate the product. I would like to show in 3D view fittings once again, and you see that program has selected the fitting here, but it can't be realized for this connection. Let's change the type double branch and branch 57. Recalculate the project, and you see that this fitting also can be selected but can't be realized in this place because of some mismatches of these connecting pipes. We can change the situation with this value, the value of rotation angle on the first node of the nodes that we have here. We can try to change this value and calculate the product. So you see that the program responded and matched the correct fitting here. So, to summarize, we should remember that for such type of connection, we can change the method of node implementation, choosing from the offered list. We can realize such connection with the use of two fittings, and in this case, this function allow implementation with two fittings should be enabled. We can realize such connections with the use of one fittings, and in this case, this function should be inactive. We can improve such connections in the situations when the program shows us that this fitting can be realized for this connection. We can change the value of rotation angle and monitor the situation changes. And also we can change the value of the gradient for each connection pipe run. And we opened another project. As you can see, it is rather large. And I would like you to pay attention to the difference in colors for the network, for the collector, and for the stacks, and also for the pipe runs. It can be realized very easily. Here in the general data, we choose component style, and for the pipe run, here you can see that we can change the name, the line type, line color, and also 3D color can be changed easily for all components of the installation. And we are back to the 3D view. And here I would like to show you how to change fittings for a group of nodes, how to do a one-time type change for multiply nodes. So please pay attention that for such group of nodes, we have method of node implementation by default, this one, branch 45. It is good here, for example, for this place. Here it is. But it is not good for such places. We have several of them in our project. So what we can do, we will choose them all with the use of Control key. We just need to go through all network, choose necessary fittings, and here in the data table, we will change the type of method of node implementation to this one, branch 87. And we can run calculations. And you see that the fittings are selected by the program in accordance with the method that we indicated in the data table. The next aspect we will cover here in this file is the connection of the fixtures to the riser, especially the connection of shower trays and bathtubs. Let's go first to the general data. And here in the storage management, for the first story, we will pay attention to this value distance from the flow of riser connection points. By default, here we have minus 0 and 10. But very often, engineers set here 0 or some value close to 0. And if we have some value here for the floor thickness of the heating floors, this elevation will be taken considering this value also, so the elevation will be even bigger than this data. And we will go back to the 3D view. Let's calculate the project. And what we can see is the red color of the icon of calculations. And here in the diagnostics window, we see such an error. Gradient of pipe run is less or equal 0. This error refers directly to the connections of the shower trays and bathtubs. This is happened because the traps for such fixtures are located under them. So we need to raise them. What we should do for such cases. Here in the project browser, we will find all shower trays, select them all, and here in data table, we will improve this position, distance from the floor, for example, to this one, and recalculate the project. So you can see that the icon is yellow now. That means that we don't have any errors in our project. And program has calculated the installation. The next case we will talk about is the connection point to the dishwasher. This point, as you can see on the 3D view, now has not acceptable view. For this case, in the Diagnostics window, we will see such a warning, PD from adjacent junctions overlap. This is just warning. It doesn't influence on the calculations of the program, but if we would like to have suitable view here on the 3D, we can improve the situation. Please note that this happens because this connection point is located from the other side of the pipe runs. Here it is on 2D, and we can just reduce the width of the dishwasher and calculate once again. So you can see that now these fittings look much more better, And now this is correct view of this connection on 3D, and we can move further and use it in our project. The next important aspect that I would like to show you here in this project is the following. Please pay attention that we have many repetitive parts in this project. This project was prepared for you like an example, and I would like to show you this case, the case of connection to the toilet bowls. And please pay attention that here we have two identical mirrored connections, this one and this one, but solution is different. That happened because here I used the method that I've previously shown you to improve this connection. I specified the value of maximum gradient 999. Also, I changed the method of declaring point of connection to the stack to user specified. And I specified also the distance from the flow of connection to the stack. Here we have many similar situations. And what you should know that we do not need to improve each separately. For this purpose, we will do the following. Let's first of all remember the properties of the reference connection. So here in the data table, we have the length of this pipe run, 1 and 41. We have location, waste branch, and also here in the hint with technical properties, we have sum of du, 2. Let's go to the search window, and here we will add new search. Let's call it connection with C. We will find pipe run with the length from 1 and 3 to 1 and 5 with the location waste branch and with sum of du from 2 to 2. Okay. Let's find all connections, select all. And as you can see, the program has selected all connections to toilet bowls. And here in the data table, I will indicate the method of declaring point of connection to the stack to user specified. I will set here -0 and 16. Maximum gradient 999, and the value of real gradient will be 30%. And let's calculate the project. Now you can see the results of our manipulations. It's not very attractive here. We just need to improve real gradient step by step. Maybe it will be 32. Let's see. Yes, everything is okay. So this is the path how we can quickly and easily find and modify several elements of the same type. By this opportunity of changing the properties for the group of the same elements, you can save a lot of time and not do it separately to each element. So I think that we can finish here. Please subscribe to us on the social networks, on FB and on LinkedIn, to stay up to date with our news, important events, software updates. Thank you for your time. Thank you for your attention. Thank you for choosing us. See you soon and goodbye.